now we actually have to start computing these guys, right? So what we want is we want the probability of seeing a document from the relevant class and probability of seeing a document from the non-relevant class. Now we can't be vague anymore, we have to specify what the document looks like. In the classical model, the representation of a document was particularly simple. What they said is a document is going to be a collection of Bernoulli random variables, one for every word in the vocabulary. So dw is a variable for the word w, and what it says is whether the word w was absent or present in the document. If it's 1, this means w was present. If it's 0, this means w was absent. So what I'm doing, in fact, is I'm representing a document as a binary vector over the vocabulary. It has 1s in those places for the words that occurred in the document, and 0s for the words that didn't occur in the document. So that's my first assumption. The second assumption is I'm going to assume that those variables, dw, they're all mutually independent given r. So if I know that the document is relevant or non-relevant, the occurrences of words, the presence or absence of words, is completely independent. Right? Now you look at that, that should raise some red flags immediately. What I'm saying is, if I'm in the relevant class, presence of Barack tells you nothing about presence of Obama. Blatantly false. Because we know that words correlate, words have positive correlations. So that's going to be a bad assumption. And a lot of the attempts to improve the classical model are targeting specifically this assumption. So it's a bad assumption. It is unfortunately necessary. If we don't make this assumption or some kind of assumption like that, we're not going to be able to move further because the event space is huge. Right? So think about what we're dealing with. Our documents are binary vectors, so effectively documents are subsets of vocabulary. Right? And our vocabulary can get quite large, and there are lots of subsets of such a vocabulary. We're never going to be able to estimate anything unless we make an assumption that allows us to factor the probability in some way. But once we make that assumption, things become simple, right? So our ranking formula from the previous slide, we're just ranking by the ratio of probabilities of the document coming from the relevant class and the document coming from the non-relevant class. And now each document is just a vector of DWs, which are all IID given R or not R. So you can just rewrite them as products over the individual DWs, right? So now I have a product over all the words. Make sure you don't mistake this. So this product goes over all the words in the vocabulary. So this is the million words that you have in the vocabulary. And you have the probability that that word occurs in a document given the relevant class, probability that the word occurs in a document given the non-relevant class. So it is identical to naive Bayes, except we don't have the priors. And again, why don't we have the priors? Because we're ranking.